Hello, welcome to my research presentation on perceived productivity. We have all been told to focus at one point or another, but I'm sure we've also found ourselves in a place where focus can seem impossible. Many things can affect how we focus, but what about the things we can't control? I personally have had times in school where I couldn't focus and it felt like something was working against me. This led me to wondering how a classroom atmosphere can affect how students focus and be productive. So first up, we have my literature review. First, I want to go over some key terms. We have perceived productivity. This is the level at which students produce high quality work. This is a measurable attribute that looks at the speed, quality, and quantity of work completed within a given time frame. Other words used throughout this paper and presentation are focus and efficiency. Classroom atmosphere refers to the overall environment or mood in a classroom, and this is shaped by the interactions between students, teachers, and their physical surroundings. Atmospheric variables are things within an environment that can affect student productivity in different ways. This first paper focuses on how perceived productivity correlates with actual productivity. To look at this, the researcher looks at the study habits of students. She explains her gap by saying that effort is very hard to measure, as there are often unmeasurable moderating and mediating variables. Different groups were allowed to complete as much or as little of a course as they wanted at one time, while getting to see the results of other students who either did exceptionally well, low, or average. She found that students seem to mimic the habits of the students around them, and that they think they are doing positively, how they think they're doing positively correlates to the results at the end of the experiment. I rely on this heavily in my research because it talks about the productivity of students, specifically perceived productivity. This study allows me to later use experimental and observational techniques to study perceived productivity, and it helps give my findings real-world implications. Next, we have this paper by Adia et al. This focuses on how technology in the classroom and other distractions affect student concentration. The researcher used a Likert-type survey to send to the subjects to analyze what students felt was the primary distractor in the classroom. They built a survey with 24 possible distractors and asked the subjects to rate them from little to no distraction to highly distracting. The results found that cell phones and abnormal classroom temperature were the highest distraction, while eating in the classroom was the lowest distraction. I chose to use this in my research as it shows how different variables can affect student concentration and focus. Finally, in this last paper, Wahlberg, Fraser, and Welch established that not many studies look at the issue of productivity on a national scale, and very few studies look at more than one or two variables at a time. With the help of government funding, they were able to administer a science exam involving over 18,000 students across 700 different high schools. After the initial testing, the authors gave the students who were tested a 19-question Likert-type survey to ask basic questions about their prior student achievement and their opinions on the benefits and importance of science. They found that of the variables observed, they all had an equal effect on student productivity. Although they did have a near equal effect, students that had an advantage over one variable often had an advantage over others. This theory is an established theory that the first author, Wahlberg, came up with and tested in a previous paper in 1981. The theory states that there are 9 key variables that affect learning and student productivity. Wahlberg further breaks them down into 3 distinct categories. First, we have aptitude. This is the ability, development, and motivation towards learning. These variables fall under students' own control and can only be affected by the students themselves. Next, under instruction, there are only 2, which are the quality and quantity of instruction. These variables fall fully onto the teacher and school system to teach children to the best of their ability. Finally, under environmental factors, there are home, school atmosphere, peer group, and external exposure to media. These variables can be influenced by a number of different people, but still seemingly affect students simultaneously with the other variables. After thoroughly looking through the existing literature, I came up with the following research question. To what extent do variables within a classroom affect Southwestern NC students' perceived productivity? Although many studies on this topic use strictly an experimental design, there is not much insight into the results that an observational study would yield. Of the very few mixed method studies out there, none look at the effect of multiple variables on productivity, usually only about 1 or 2. Now we have my methodology. Going into this project, I started off with the hypothesis that the more extreme a variable was presented in the classroom, the more it would decrease a student's productivity. I thought that the more noticeable it was, the more likely it would become a distractor to the work at hand. To fully understand how students felt about their productivity, I had to work off of two different assumptions. The first is that students are going to try their best to do work no matter the situation. This would allow any variation in responses to be due to the classroom atmosphere rather than factors outside of the classroom. The second assumption is that students will retain about the same amount of productivity no matter the assignment or task they are given. This eliminates any need to take into consideration individual differences in task complexity, personal interest, or cognitive load. To thoroughly study the effects of the classroom atmosphere, the study combined a correlational approach with an experimental design to contribute to creating new data while still aligning with other studies. Although many studies on this topic use strictly an experimental design, there's not much insight into the results an observational study would yield. One study by Addy et al. Made use of an observational study that highlights the practicality of using an observational approach to obtain answers directly from students. To allow the current study to use observational techniques, the study also incorporated some experimental techniques similar to those of Wahlberg et al. To keep in alignment with the majority of studies already conducted. So for the sample, the students were selected through a block random sample to obtain the most accurate and unbiased results possible. The school is broken into three main sections: the first building, the second building's first floor, and the second building's second floor. Classrooms within those sections were randomly assigned a number with a random number generator arbitrarily picking classrooms from each section. To determine the number of classrooms to be used in the study, I just picked one classroom to be surveyed for every 5 in each section. 1 to 3 classrooms were chosen from each section to provide a big enough sample size to help eliminate cognitive bias, while also allowing to have enough time to complete the study within the required time frame. The participants in the study consisted of 109 high school students. The students selected had to attend class in person and be regularly instructed by a teacher in person throughout the course. Of the 5 classrooms selected, 3 were from the top floor of the second building, 1 was from the bottom floor of the second building, and 1 was from the first building. Students were further broken up by class period to maintain a more representative sample. Before participating in the survey and experiment, students were provided with an informed consent form breaking down everything that would happen in the experiment. To be included in the survey, the student must have stated that they read and consented to the terms listed on the form. After students completed the consent form, they were presented with a 12-question survey that consisted of 11 Likert type questions and 1 free response question. The survey was presented through a Google form attached to the student's email. In the survey, there were 5 atmospheric variables asked about in the Likert type portion of the survey. These components, lighting, temperature, classroom decor, seating arrangements, and class size, acted as the independent variables. These variables were chosen because they had a similar structure to the variables used in Wahlberg's theory of productivity. The first question asked the participants to rate the presence of the variable within their atmosphere, and the second question asked how much the student felt it impacted their ability to focus. According to the variable most answered in the free response question of the survey, I had the teacher change that variable in the classroom for a 2-week period if it was within needs. I chose 1 class period from each teacher to change their assigned variable, establishing an experimental group, while the other was kept the same as a control. For the duration of this experiment, aside from the change variable, all other aspects of the classroom remained the same. Teachers continued with their lessons and teaching as planned prior. After the 2-week period of the variable being changed, the original survey was administered again to see if the results linked with the independent variable had changed. The initial survey responses revealed various trends regarding students' perceived productivity in relation to different classroom and environmental factors. Demographics of the students who responded, such as age, gender, and race, were not collected in this study, and overall productivity ratings varied based on the presence and extremity of these factors. The raw data from the initial survey was taken and plotted on a graph based on which variable it pertained to. The data was then ran through a least squares regression test to calculate the line of best fit for each variable. This resulted in 5 different graphs with varying trends and patterns. The first variable measured, and possibly the most unexpected, was lighting. The initial survey data showed that there is a negative trend between the presence of lighting and perceived productivity. When the intensity of light increased in the classroom, perceived productivity decreased, as you can see on the graph. According to the free response question at the end of the survey, 9 students mentioned that they took great notice of the lighting in the classroom. Similar to lighting, perceived class size also had a very steep line of best fit. This trend suggests that there's a strong positive relationship between class size and productivity. Although the data I collected suggests that the bigger the class size, the more productive students are due to the rapidly increasing slope, this data contradicts most data existing in current scientific research. Contrasting lighting and class size, the seating arrangements variable had such a wide range of answers that the line of best fit was almost straight. When answering the free response question, only 4 students mentioned the seating arrangements of their class. The last 2 variables, temperature and class decorations, had very similar results. Their line of best fit curves followed similar trends and are almost identical. The average productivity rating was slightly higher for decorations, but not by a significant enough value to suggest a relevant difference between the two. Both variables showed slight positive trends, indicating that while increase in temperature or class decor may have some influence on student productivity, their effects are relatively small. Although their lines of best fit were very similar, 33 students mentioned decor when asked about what they noticed most in the classroom, while temperature only had 5 students explicitly mention it. When combining the variables together, the students were left with an overall moderately high level of perceived productivity. Students who rated their overall productivities low most often had the lowest productivity on each of the other variables when separated. This reinforces my hypothesis that a combination of factors contributes to a more productive learning environment, albeit some more than others. In the study, the data found in the first survey was used as a baseline to compare to the post-survey administered after the experimental period. After analyzing the initial data, this information was then used to evaluate whether changes in a single variable corresponded with a shift in perceived productivity. First, the standard deviation of each column was calculated. Each variable was split apart from each other and then split again further by response. This means that under each variable, all ones were grouped together, all twos, and so on. The standard deviation was then taken for the productivity of each group to see if the results had any significant meaning. The mean standard deviation of all of the subcategories was then taken to provide a clear summary of the data. The mean standard deviation of the variables fell within a range of 1.2 to 1.7. For the small range of possible values, the standard deviation is relatively high, meaning that the data is not largely significant. These results align well with the ideas presented by Adia et al. By showing that what works for one student will automatically be applicable to another. The F-test was then used to see if the variance of the singular variables was noteworthy. To calculate the F-statistic, the mean of the standard deviations of the single variables was divided by the standard deviation of overall productivity and then squared. This gave an F value of 1.1. When compared to the F distribution table, the calculated F value was smaller than the critical value. This shows that the singular classroom atmospheric variables do not have a significant influence on perceived productivity and each other. This finding contradicts many data sources like Wahlberg et al., but it does align with other sources like the findings of Valero Valenzuela. This similarity shows that there are many outside factors that affect education that don't have to relate to the environment. Although the analysis of the results of the first survey were not significant, the post-survey results were still compared to see if they followed any trends or patterns. As expected, the results of the post-survey seemed arbitrarily placed when plotted on the original graph. This further affirmed that there was no correlation between variables. This study did have a few limitations that likely impacted the results. In the first survey, I was able to obtain data from 109 students, and while this provided a manageable sample size, only a small fraction of the original participants completed the post-survey. Many students likely did not respond to the post-survey on account of it being sent out the last day of the semester. This resulted in a large amount of non-response bias, leaving the results much less applicable to the population of interest. Although the study aligned with 2 well-regarded studies within the scientific community, it still failed to take into account a few variables that could affect results. Other sources, such as Valero Valenzuela, as mentioned before, assert that factors within a social climate affect students more than their environment. My study did not measure student instruction quality, motivation, intellect, and interest in the subject, which could all play a role in how productive a student might be. This survey did not take into account if students had any learning or attention disabilities either. Certain conditions that can affect learning, such as ADHD, were not observed. These conditions can have major effects on student productivity and can completely shift results in a different direction than they would have for a student who does not have these conditions. Additionally, one participant in the study is blind, so variables such as decorations and lighting would not be significant to their learning as they would to others. In a replication of this study, conditions such as these should be taken into consideration to allow the researcher to fully understand all of our variables that play with productivity. There are also a few changes that should be made to the study if it were to be replicated. First, the study should reduce the risk of losing a majority of its participants. This would allow the study to be better maintain a representative sample and reduce non-response bias. Second, the study should better take into account other potentially confounding variables like intellect and instruction quality and other unmeasured variables like student motivation. Finally, the study should be recreated in an environment where changes to classroom variables could be made more easily. In a school classroom environment, there's only so much that a teacher can change, and this made it very difficult to effectively change a variable as there were a very limited number of things that could effectively be changed. While these specific results prove that learning is very individualized, this methodology could still be used. Teachers could use a similar survey for their own classes to see if students are benefiting from the environment they created, and they could also use this as a guide to see what works best for their own classroom. This information could be used by school administrations to get a better gauge of classroom effectiveness, which they can in turn use to create school or district-wide policies, uniform classroom layouts, or even help teachers become more receptive to their students' needs. Overall, the data obtained from this study is not entirely useful for the scientific world as it is, but it would be very beneficial to attempt this type of experiment again with some improvements to see if more conclusive results can be achieved. And then here are my sources. Thank you.
Yeah. Sonia, would you ask the first question?
Yeah. First of all, great job. It's really interesting,
Thank you.
really interesting research. But how did your initial exploration of this conversation lead you to this project goal? Walk me down that path of your thought.
In my initial exploration, I looked at a range of studies that explored the impact of learning environments on student performance. I noticed that much of the existing literature focused on broader school level factors like teaching style or curriculum, but fewer studies took a detailed look at the specific environmental variables within the classroom itself, such as the ones I used in my research like lighting, seating arrangements, noise levels, or temperature, and how those influence student productivity. This gap in the research helped me refine my focus and developed a research question aimed at identifying which specific environmental factors most significantly impacted classroom productivity from the student perspective.
How did the limitations of your method or data influence your new understanding?
The limitations of my data and method made me realize that there's still a lot to understand about student productivity. There are so many things that go into a student's ability to learn and retain new information, let alone adding productivity into the mix. My non-significant results also made me realize that it is very important to focus on the bigger picture rather than trying to break down everything into little bits and pieces while ignoring some of the bigger chunks of information.
Anyone ask last questions?
Oh,
Just on number 5.
okay. We kind of did one already, so I'm going to go with 2. How did you handle the uncertainty of your research project? Because I think the more you got into it, the more questions you had.
I handled this uncertainty by trying to stay as flexible as possible and open to any unexpected outcomes. When things didn't go exactly as planned, like dealing with scheduling issues or getting my insignificant results, I focused on what I could control, like refining my analysis and reflecting honestly on what the data showed. And I learned that research isn't always about proving something, it's about learning from the process no matter the outcome.